In this video, we will be continuing our discussion on conditional statements, which we introduced in our propositions lesson. When you have a conditional statement, you can derive three related statements known as the converse, inverse, and contrapositive. If you recall from our propositions lesson, a conditional statement takes the form of if P then Q, denoted as how you see it written on screen. We also went over truth tables in our propositions video, and I'll remind you of the one for conditional statements here. We refer to P as our hypothesis and Q as our conclusion. The only time we can have a statement that is false is if we start with a true hypothesis and end with a false conclusion. If we start with a statement that is false, regardless of if our conclusion is true or not, the entire statement is true because we are starting out with a hypothesis that is incorrect. You cannot conclude anything from a false hypothesis. So what about our related statements? Let's start with the converse. To get the converse of a statement, you would switch the order of the hypothesis and conclusion, or P and Q. Say we start with the statement, if 1 plus 1 equals 2, then 2 plus 2 equals 3. We have that P is true and Q is false, so the truth value of the entire statement is false. If we take the converse, which is just switching the order of the propositions, we have if 2 plus 2 equals 3, then 1 plus 1 equals 2. In this scenario, we have a P that is false and a Q that is true. So the truth value of the entire statement is true. Here's a truth table that includes both the statement and the converse. Notice that the truth values in the final two columns do not match up. Because of this, we say that the statement and the converse are not logically equivalent. This is not to say that a statement and its converse cannot hold the same truth value. As you can see, it happens twice in our truth table. It just won't happen every time. Moving on to the inverse of a statement. To take the inverse of a statement, we negate each of the propositions. We'll keep with the same example. If 1 plus 1 equals 2, then 2 plus 2 equals 3. Again, P is true, Q is false, and the truth value of the entire statement is false. The inverse of this statement is, if 1 plus 1 does not equal 2, then 2 plus 2 does not equal 3. We see now that the P has become false and Q has become true. Since our hypothesis is false, the truth value of the entire statement becomes true. Here is a truth table that includes the inverse in addition to the original statement and converse. As you can see, the truth values in the columns for the converse and the inverse match exactly. This is because they are logically equivalent. If the converse of a statement is true, the inverse of a statement is true. The same can be said if one of them is false. As you move on in mathematics, this fact may be useful when doing proofs. Finally, we move on to the contrapositive. The contrapositive of a statement is sort of a combination of the converse and the inverse. With the converse, we switched the propositions. With the inverse, we negated the propositions. So to get the contrapositive, we must switch and negate the propositions. Sticking with our example, if 1 plus 1 equals 2, then 2 plus 2 equals 3. Again, P is true, Q is false, and the truth value of the entire statement is false. To find the contrapositive, we switch and negate, so we have, if 2 plus 2 does not equal 3, then 1 plus 1 does not equal 2. Now we have a P that is true and a Q that is false, so our statement is false. Do you think that a statement and its contrapositive are logically equivalent? Let's look at a truth table. We can see that the truth values in our columns for the original statement and the contrapositive match up. So that tells us that these are logically equivalent. Like with the converse and inverse, this may be helpful in the future for proving various theorems in mathematics. Instead of proving a statement directly, you could prove its contrapositive if that is easier for you, and you would still have a sound argument. To summarize, the converse, inverse, and contrapositive of a statement are just variations using the individual propositions, either by switching their order, negating them, or both. If you thought this lesson was helpful, make sure you like this video and subscribe to stay up to date on our latest content.